This is Module 1, Lesson 7. We're talking about scientific notation. Now we're going to use our exponents we've been talking about, and we're going to use them to express very large or very small numbers using scientific notation. For instance, if we're talking about 350 million, we can express that in scientific notation. You know that there is an understood decimal at the end of this number here, and all we have to do is see how many places we've moved it. 1, 2, 3, 4, 5, 6, 7, 8. 3.5 times 10 to the 8 expresses this number with fewer decimals, with fewer zeros, and it makes this easier to understand. Scientific notation is a way to write very large or very small numbers by using powers of 10. See, times 10 to the, and there's your power of 10. A number in scientific notation consists of two factors. The first is a number greater than or equal to 1 and less than 10. Up here, that number was 3.5. That's between 1 and 10. The second factor is the power of 10. In this case, that's times 10 to the 8. An example would be 532,000 written in scientific notation, which is 5.32 times 10 to the 5th. Look, you know there's an understood decimal here. You'd move it 1, 2, 3, 4, 5 places to have 5.32 times 10 to the 5th. If the exponent is positive, it's a big number. Exponent positive gives you a big number. If the exponent is negative, you get a small number, okay? Something less than 1. This is bigger than 1, that's less than 1. To write a number in scientific notation, move the decimal point until the number is greater than or equal to 1. See how we did this here? It's 5.32. That's greater than 1, but it's less than 10. Count the number of places the decimal point moved. In this case, you moved it 5. Write the number as the product of the first number and 10 to the power of the decimal places moved. Notice, we moved 5 places. Here's your number that's between 1 and 10. Here is our power. We've moved the decimal 5 places. It is a positive number, so it means it corresponds to a very large number. If you move the decimal to the left, the exponent will be positive. If you move the decimal to the right, the exponent will be negative. Notice, in this place, we move the decimal to the left. So the exponent was positive. If you move the decimal to the right, the exponent is negative. That's not something you really want to try to remember. Your best bet is to remember this. Very large numbers come from positive exponents. Very small ones come from negative exponents. Okay? So let's look at a couple examples. What is 7,800,000 written in scientific notation? Well, we want this to be, the front number to be between 1 and 10. So we move this 1, 2, 3, 4, 5, 6 places. That would be 7.8 times 10 to the, we've moved the decimal 6 places. Is it a positive 6 or a negative 6? Well, this number is much greater than 1, so it's a positive number. What is 567 billion written in scientific notation? Well, we know it's going to have to be 5.67 because that's between 1 and 10. How many places am I moving the decimal? That decimal's understood to be there. We're moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Times 10 to the 11th. Okay, is it positive 11 or negative? This is a very large number, so it's a positive exponent. What is 0.00405, which is 405 thousandths, written in scientific notation? Well, we need to have a number between 1 and 10. We move the decimal, so we will. Okay, if I put it right there, I'd have 4.05. That's between 1 and 10. And that is times 10 to the, let's see, I've moved the decimal 1, 2, 3 places, right? You see that decimal's between these two zeros. I made it 3 places. Is it a large number or a small number? This is less than 1, so that's times 10 to the negative 3. What is this number written in scientific notation? Well, if we look at this, guys, our numbers here, 6.711. That gives me a number between 1 and 10. How many places do we move the decimal? This is counting the number of places we move the decimal to figure out our exponent. We move the decimal 1, 2, 3, 4, 5, 6, 7, 8 places. Is that a positive 8 or a negative 8? That number was less than 1, wasn't it? So it's a negative 8. And then finally, what is 9,901,000 written in scientific notation? Well, our decimal needs to go here, right? 9.901. Okay, times 10 to the, well, this number is bigger than 1. So we go 1, 2, 3, 4, 5, 6. That's times 10 to the positive 6. It's bigger than 1. Your exponent is a positive number. Okay? Now, let's look at some of these. You can change a number in scientific notation into standard form. Okay? We did that just a minute ago. Let me show you the difference between standard form and scientific notation. This would be standard form. It's what you're used to seeing written. This is scientific notation. Down here, this is standard form. What we wrote was scientific notation. If the exponent in scientific notation is positive, and you're trying to change it to standard form, which way would you move the decimal? Okay, let's look at this. What if I have 6.1 times 10 to the 4th? We know this is a big number because the exponent is positive. 6.1. That means I'm going to move that decimal 4 times this way. 1, 2, 3, 4. I'm going to make a big number. I'm moving that decimal right? If the exponent in scientific notation is positive, move the decimal point to the right. I'm not expecting you to memorize which way to move it. I want you to think in terms of, is this a positive exponent or a negative one? Positive is going to give you a bigger number. Negative is going to give you a small one. If the exponent in scientific notation is negative, move the decimal point to which way? Well, let's see. If I had 2.3 times 10 to the negative 4th, that means I need this 2.3 to be smaller than it currently is. Smaller than 1, so I'd move it 1, 2, 3, 4 places, right? That's 0.00023. Okay? I've moved the decimal point, not the number of zeros. How many places did I move the decimal point? I moved that decimal point to the left. And notice I had to, if you may have to add some zeros, okay? Sometimes you got to add zeros. I did here. Add zeros if necessary. You know, zeros in the front might have to be added as you're doing that. What is 8.3 times 10 to the 4th in standard form? Okay, let's try this. 8.3, and this is a positive exponent. It tells me how many places I moved the decimal. I moved them 4 to make the bigger number. 1, 2, 3, 4. Positive exponent gives you a big number, and I've got 83,000. See, that's a big number. It's greater than 1. What is 9.47 times 10 to the negative 5th in standard form? Negative means we're making a smaller number. 9.47. To make a smaller number, I'll move the decimal this way. 1. See, I got to put in zeros here. 2, 3, 4, 5. Okay? So what I'm looking at is 0.0000947. And you can put a 0 here in the front as a placeholder. That's the number we're looking at. It's a negative exponent, so it's going to be something less than 1. Let's talk about the size of these numbers. Okay, I want to compare some real quick. Let's just put us a little more room down here. We're going to compare some. 8 times 10 to the third and 7 times 10 to the fifth. Which one of these would be a bigger number? Well, I'm sure a lot of you are just looking at this front number and thinking, oh, this one's got to be it. But no, look at your exponent. Your exponent is what's important here. Let's use your exponent to see what this number is. You know there's an understood decimal here. And I would move it 3 places this way to make it bigger. 1, 2, 3. I'm talking about 8,000. What if I've got 7 here? There's an understood decimal there. And I'm moving it 5 places. 1, 2, 3, 4, 5. Okay, and you're talking about 700,000. This number is a whole lot bigger. 700,000 is a whole lot bigger than 8,000. The first place you look is always at your exponents. Okay? Now, let's look at this one. What if I'm comparing 3 times 10 to the negative fourth and 5 times 10 to the negative sixth? Which one is bigger? Well, let's look at this, guys. Once again, we should be looking at the exponents. Which exponent is bigger? If you're looking at a number line, 0, -1, -2, -3, -4, -5, -6. Look, -4 is actually farther up the number line than -6. So -4 is a bigger number. This should be my biggest number. Now let's check it and see. 3 times 10 to the -4. I've got 3. I understood the decimal is there, but times 10 to the -4 means I make it a smaller number. I'll move it 4 places. 1, 2, 3, 4. Okay? This is 0.0003. And let's try this number here. 5 times 10 to the -6. You'd start with 5. You understand your decimals there. And I'm going back 6. I'm making it a smaller number by 6 places. 1, see, it's not number zeros, it's how many places. 1, 2, 3, 4, 5, 6, okay? So I'm looking at 0.00005, and zeros in the front. Which number is bigger? You can put in zeros behind this if you need to see it. And if you line up your spaces, you can see. Your 0.0003 is bigger. This is your bigger number than the other one. Okay, because there's more zeros in front of this 5, right? Okay. You can tell that too from the exponents. This is a bigger exponent than this one. I was looking at these two. This is a bigger exponent than this one.